Well, we're now going to go over our basic exponential decay example. So our example is a rubber bouncing ball will rebound to 7/8 of its drop height when dropped if nothing is in its way. Suppose one of these balls is dropped from a height of 75 feet. Write a function rule and a now next rule showing the height of the ball after each bounce. Like the previous example, we want to start by identifying the important information, such as the start height, decay rate. In this case, we have an event instead of a time period. And we'll use these things to write our function rule and our now next rule. So first, let's see if we can identify the start height. The rubber bouncing ball will rebound to 7/8 of its drop height when dropped if nothing is in its way. Suppose one of these balls is dropped from a height of 75 feet. All right, we have this 75 feet. All right, that is our start height. And we'll add that into here. Next, a decay rate. So what is the amount of this height that is left over after each bounce? That's up at this first line here where it says 7/8 of its drop height. We have a decay rate of 7/8. All right, and the event is the rebound or the bounce. So we have one bounce. Excellent. Now we get to the function rule. We have all the information that we will need. All right, so we will start again by just reviewing what a function rule looks like. It has the form y equals a times b, an exponent of x. All right, once again, y is the name of the function, a is our start value, b is our decay rate, and x is the exponent. It represents the number of events that have happened. In this case, y and x will remain the same. We'll have y equals our start height of 75. And then we have the decay rate of 7/8 with an exponent of x. And quickly, let's go through and label these parts again so we don't forget. We have 75 is our start value. And 7/8 is the decay rate. Excellent. Now we have the now next rule. We'll use the same important pieces of information, such as the start value and the decay rate, from our function rule to write our now next rule. All right. We have next equals now multiplied by b, comma, starting at a. This is what it's going to look like. Once again, we've seen this a few times. I'm just continuing to show it so that we don't forget. That means our rule will look like next equals now multiplied by 7/8. Comma, starting at 75. All right. So once again, we have our decay rate, start value, decay rate. All those pieces are there. We could also choose to write this kind of in the flipped way and go now times 7/8 equals next, comma, starting at 75. These two, this rule and this rule, are the same. We've just flipped the order that we wrote them, but the same things are on different sides of the equal sign. They're the same equation, just flipped. All right. Now that we have our function rule, we have our now next rule. We're going to move on and do the table and the graph of this situation so that we can kind of see what it looks like. Again, I'm going to start just by rewriting our function rule, which is going to be y equals 75 times 7/8 with an exponent of x. All right. This is the rule that we will use for the table and on the graph. Our table, right, our x values are going to be the number of bounces. Right, essentially, how many times has this thing bounced back up in the air? We'll fill this into the table. Our y values will be the ball height. And this will be in feet. So we'll have, starting with 0 bounces, 1, 2, 3, 4, and 5. When we have no bounces, the ball hasn't been dropped yet, we are sitting at a height of 75 feet. After one bounce and multiplying by 7/8 one time, we're at a height of 65.6 feet. After the second bounce, we'll be multiplying by 7/8 again. We'll be at 57.4 feet. After the third bounce, we'll be at 50.2 feet. After the fourth bounce, we'll be at 43.9 feet. And after the fifth bounce, we'll be at 38.5 feet. So this isn't decreasing really fast. However, it is decreasing exponentially when multiplying by the same thing each time. Now that we have a table, we can make our graph. All right, so let's set up the parts of our graph that we need. The bottom here will be the number of bounces. All right, and our y-axis will be the ball height. Again, in feet. All right, so let's label this. We can kind of spread out our x-axis. 1, 2, 3, 4, 5. We'll put the sixth one here just for fun. We're not going to have the number for it. Now on this one, we at least have to start at 75, right? So up here should be 75. I think if we go by tens here, we should be good. So let's go 10, 20, 30, 40, 50, 60, 70. All right, and we'll do little marks in between for 5 spots. All right. So that means that this right here will be 75, even though we didn't write 75 next to it. We know that that's what it is. All right. So now let's mark our points using our table. At 0, we're at 75 feet. So we'll put a mark at 75 right on the x-axis. Then we will do our next point is at 1. We're at 65.6. All right, the next point at 2 will be at 57.4. Again, we're estimating. We're going to do as best as we can. But, you know, it's written by, done by hand. It'll have a little bit of error, and that's fine. We're okay with that. 50. I think I need to move this guy up a little bit. And we'll fix that and we'll go right. Helps if I'm back on the drawing part. Okay. There we go. And at 4, we're at 43. All right. And 5, maybe around here. All right. So, I mean, it looks pretty darn close to a straight line right now. And that's okay. Again, we're getting as best as we can. We can connect our dots here. We can see that it's decreasing. And I connected as best as I could. You can see it's slightly curved, and that's our graph. We can use all this information in the function rule in our calculator to answer different questions about this. We're not doing that right now. We're just trying to get a sense of finding the information, seeing what it looks like in a table and a graph, getting the rules. If you have any questions, please email me. Stay tuned for more videos and examples.